Good afternoon, everyone. For those of you who don't know me, I'm Charlie, a software developer in the Jade platform team, and today I will be talking about the new event streaming feature that has recently been released in Jade 2022 Service Pack 3. Firstly, what is event streaming? Event streaming is a mechanism to continuously publish data from one or more systems to a central broker. The central broker is usually a part of a cloud-based event streaming platform like Azure Event Hubs or Confluent Kafka. It handles the storage and management of the event stream. It is the core platform that enables the seamless distribution and access to the events by consumers. So, in the context of Jade, what is an event? An event is a record of a change in state within a persistent transaction. For example, you've got a persistent customer object and you update the name property and commit the transaction. That would be an event. Now, before we get ahead of ourselves, there are several architectural consequences and considerations that must be addressed when implementing event streaming. Firstly, the publisher-subscriber model. This is where systems will publish events to topics, and other systems will subscribe to a particular topic or set of topics in order to receive data from the publishers. Asynchronous model. Event streaming in Jade occurs asynchronously. It happens in the background while your application is running. There's no need to explicitly call into a REST API or a web service. Eventual consistency. This means that data updates propagate asynchronously, ensuring all systems reach the same state, just not instantly. A crude example of this would be sending a message to a group chat. Some members of the chat will instantly see that message, while others might see it a few seconds later. It depends on what they're doing. Horizontal scaling. Horizontal scaling in event streaming can be achieved by dividing data into partitions, or rather, logical channels. Each channel is processed independently, allowing multiple consumers to handle them in parallel. For example, a stream of financial data could be partitioned by region. At least once delivery semantics. Event streaming in Jade guarantees that an event will be delivered at least once, but under failure or exception conditions, it may be delivered more than once. This decision was made due to the performant behavior of at least once delivery semantics. However, this means implementations of event streaming must be idempotent, or rather, consumers must be able to receive the same event twice without changing the state of the underlying data. Flexible routing via topics can be used to direct events to specific channels based on the event's type. Consumers subscribe to relevant topics, ensuring they only receive specific events. For example, in a banking system, a dashboard focused on customer insights wouldn't need to access confidential financial data. By routing only the customer data to a customer data topic, the dashboard application could only subscribe to the customer data topic, and therefore would only see events pertaining to customer data. Now, let's look at some example use cases of how event streaming can be utilized to add value. Integration of discrete systems. Event streaming enables seamless communication between otherwise isolated systems by continuously transmitting events in real time. This integration allows for synchronization of data across different platforms, ensuring that all systems are updated with the latest changes as they occur. Event-driven microservices. In an event-driven microservice architecture, each microservice responds to events published to the stream, triggering specific actions or workflows. This approach enhances scalability, flexibility, and near real-time processing via loose coupling and asynchronous interaction through events, rather than tight coupling via direct calls. Real-time data analytics. Event streaming facilitates the processing and analysis of data as it's generated, enabling real-time data insights, such as live dashboards. IoT integration. Many IoT devices support event streaming. It enables the continuous flow of sensor data to processing system for immediate analysis. This drives automation, monitoring, and information-based decision-making. Now, let's explore some key benefits of event streaming. Decoupling. Event streaming decouples systems by enabling producers and consumers to communicate through events. This reduces direct dependencies between systems, enabling greater flexibility in how they evolve or scale. Scalability. Event streaming supports scalability by allowing systems to handle massive volumes of data across distributed environments. As the volume of events increase, platforms like Kafka can scale horizontally, ensuring that performance remains high, even with growing data streams. Observability. Event streaming provides a real-time, continuous view of what's happening across your systems. By capturing events as they occur, you can gain deep insights into system behavior, performance, trends, and anomalies. Resilience. Event streaming enhances system resilience by enabling data replication and fault tolerance. If part of your system fails, the event stream continues to operate, and events can be replayed from a durable log, ensuring minimal data loss and quicker recovery. Now, we'll take a high-level look at the Jade event streaming architecture, so you can see how your data gets from your Jade system to your target applications. In the diagram on screen, the first column represents the Jade system, which includes the Jade database, database journals, and a model description file. The second column shows the Jade change capture process. It shows that events are extracted from the journals for whitelisted classes and stored in binary capture files called change capture files. The third column shows the Jade event stream producer. The event stream producer works by processing the change capture files. It achieves this by using the schema definition contained in the model description file to convert the binary change capture files to JSON formatted events. It then sends the JSON events to a specific topic on an event streaming platform like Azure Event Hubs or Kafka. The fourth column represents the event streaming platform, which acts as a broker. The event streaming platform is configured with various topics and partitions. It is responsible for receiving, storing, and managing the events, topics, and partitions. Lastly, the fifth column shows the event stream consumers, which are configured to continuously read from specific topics and partitions. Once the data from the event stream has been consumed, the consumer can use that data in various ways, such as populating a relational database like SQL or generating real-time visualizations for management insights. Let's take a deeper look at how the Jade change capture application works. It is a Jade application that runs on the database server. It creates events for add, update, and delete operations that are applied to persistent objects. The change capture application does not require you to write any Jade code. You just need to specify the classes which you want events to be generated for in your Jade any file. As for deployment, it is possible to run the Jade change capture application on both the primary and secondary nodes. However, running the application on a secondary node will result in higher latency due to the time it takes for the journals to be transferred to the secondary system. Additionally, the change capture application can be started automatically through an any option, or it can be started manually. The change capture application extracts events from the Jade system by directly reading the journals as opposed to querying the database. This results in faster generation of events compared to reading directly from the database itself, as the Jade database uses write-ahead logging, meaning it logs transactions to the journal before they are applied to the database. The change capture application reads each audit record in turn and tracks the hot end of the current journal. This implementation allows a complete list of all data changes in their exact order of application to be extracted as events in near real time. It also means that only committed transactions are captured. Events are output to change capture files. One change capture file is generated per committed transaction, and they are stored in binary format. The change capture application stores a before or after image in the capture files for each event, with creates and updates resulting in after images and deletes resulting in before images. Now we'll have a look at the Jade event stream producer. The event stream producer reads the binary change capture files that have been output by the Jade change capture application. It retrieves class information from the classes included in the event, which it gets from the model description file. It generates event schemas and registers them. The event schemas define the structure for describing events. They act as a data contract between the producer and the consumer. It serializes the events into a JSON format. Then, it sends the events to a specific topic on Kafka or Azure Event Hubs. Now, we'll have a look at the event consumer. Consumers connect to Kafka or Event Hub instances and subscribe to one or more topics. Whenever an event is published to a topic the consumer is subscribed to, the consumer receives that event. What the consumer does with the data contained within the event is entirely up to it. Consumers commonly trigger workflows and actions based on event content, or store the data for later use. For any given topic, multiple consumers can subscribe and process events independently. Consumers can be written in any language, but C# and Java are popular choices because of the available libraries. One key responsibility of a consumer is ensuring idempotency. This is making sure the same event isn't processed multiple times in a way that causes unintended effects. One approach is to design operations so that applying the same event multiple times results in the same outcome. Another approach is to track event IDs and use them to filter out duplicates. However, deleting an object will result in the event containing a before image. This means consumers will need to look at the event type if a duplicate ID occurs and determine what to do, rather than just throwing the event away. Now, let's look at the structure of an event which has been generated by the Jade change capture application. Each event contains metadata and user data. The metadata contained by an event is the type of the event, for example, a create, update, or delete. The event ID. This is a unique ID based on the database's UUID and the object ID. The sequence number. This is a monotonically increasing integer that can be used for ordering events. A timestamp, which is taken when the state change was audited and is in Coordinated Universal Time, or UTC. A schema registry ID. This is a unique ID for the data contract stored in the schema registry. It is different for each version of the class. A class name, number, and version. A transaction ID, and an object addition. The user data contained in an event can be properties, including public and protected, such as attributes, including slobs and blobs, and references, which are sent as an OID with information about the referenced class. There are some limitations. For example, Jade event streaming does not currently support creating events for collections and primitive arrays. Now, let's dive into the demo, where I'll be configuring and enabling event streaming on an existing Jade system. Before we begin, a quick note. The system I'm using, including the Jade system, Event Stream Producer, Event Stream Consumer, and SQL schemas, will be available for download, as an example, in the near future. So, I'll start with the Jade system that I'll be using for this demo. This is a pretty ordinary Jade system, in the sense that the Jade Change Capture app, or any event streaming, has not been configured or enabled on the system. We have a quick look at the system itself. It's a pretty simple system. It has a few classes and a Jade script that reads data from a static file and uses the contents to create some instances of our class. So I'll just run that Jade script to create some data. And as expected, we now have some objects. Now, if we go and look at the Jade system directory, it looks pretty ordinary and is what most of us would expect from a Jade system. Now, I'll just go and get rid of that data, so we're back to square one. And I'll close down the Jade system, the application server, and the database node. Now, the first step to event streaming with Jade is to configure the Jade Change Capture app. You can do this from the Jade ini file. The first thing I'm going to do is send a persistent DB option called Use Journal Descriptions and set this to true. Now what this does is it generates the model description files that the Jade Event Stream Producer uses. Now you need to create an event streaming section. Now the first thing in the event streaming section is to define the capture include class list. I'm just going to copy this over because it's quite long. But what this is essentially saying is the account class, the customer class, the district class, and the transaction class of the bank model schema that we want the Jade Change Capture app to capture creates, updates, and deletes, and output those to binary change capture files. The next thing we want to do is to define the capture root directory. Now what this is this is the directory where those binary change capture files will be output. I just want them output here, so I'll just copy this directory, paste it in here. Now the last thing we need to do, well, we don't need to do it, but I'm going to do it, is to set the auto start change capture to true. Now what this does is when you start your Jade database node, is it automatically starts the change capture app. You can start the change capture app manually, but why would you? So with this done, I'll close out any file and I'll restart our Jade system. Now that our Jade system has been restarted, you can see we have a new change capture folder here. Now there's a few events in here, and these are just ones that the change capture app has created from me creating and deleting objects since I last was using this app. So I'm just going to delete them, go back to our system. Now in the system, I'm just going to run the load data script again. Now if we go back to our Jade system directory, go into the change capture folder, we can see that we have two change capture files. Now I'm just going to delete the data. So we're back to square one. And we see another Jade change capture file. So I'm just going to delete all of those. Now the next step is to configure the Jade event stream producer. Now the first step here is I'm going to create a shortcut or a batch file that starts a Jade event stream producer. Now in this shortcut, you want to tell it to start the Jade event stream producer executable. Then you want to reference the Jade event stream producer configuration file. Lastly, you want to give this producer a name. I'm just going to call it the Jade event producer. The name part is important as you can have multiple event producers running simultaneously. Now that this has been configured, I'll go into the Jade topics JSON file. Now what this is a mapping between your Jade classes and Kafka or Event Hub topics. So I'm just going to copy these in. It's a bit long. But what this is eventually saying is for the account class, the customer class, the district class, and the transaction classes of the banking model schema, we want all of these events to be published to the all Jade events topic. So with that done, I'll close that. The next step is the actual Jade event stream producer config file. So a lot of this is already filled out, and you can get one that is basically a skeleton of what you'll need in the event streaming PDF. This is based on the Kafka sender configuration example, as I'll be using Kafka for this demo. So the first step is to configure or give it the capture directory. And this is just the file or the directory where Jade has output the change capture files. So it's this one. So I'll just copy that in. Now you need to use double slashes here. Now the next step is to configure the undeliverable directory. So this is just where, let's say, your event stream producer grabs one of those change capture files and it serializes it into JSON, and then it goes to send it up to Kafka. But for some reason Kafka's offline and the delivery fails. It will then output those files to the undeliverables directory, just so that you know they haven't been sent and so that you can resend them if you want to. I'm hoping nothing's going to go wrong in this demo, so I'm just going to give it the same directory as the capture directory. Now the next step is the file topic manager topic file name. Now what this is the mapping from Jade classes to topics. This is what we described here. So we just want to give it a link to this file. So if I go back to here into the producer folder, my Jade topics, and I'll copy as a path. And I'll just put this in here, and then I add the double slashes. Now, the next is the catalog directory, and this is the directory of the Jade description file. This is generally in your Jade system journals directory, right here. You can see that this one was created a while ago, and that's because a new description file will only be generated if your class changes in a structural way. So I'll copy this, paste it in here, and I'll add the double slashes. The next step is the Bootstrap server and security protocol for Kafka. Now, my Kafka is being hosted on WSL, and it's on 172.22.90.175, and it's running on port 9092. Now for the security protocol, I'm just going to use plain text for this demo to make it simpler. But if you want to use encryption, you can use SASL_SSL. Now, for the file storage provider root directory, this is just where your slob and blob data will be stored. For this demo, won't be generating any slob or blob data, so I'm just going to give it a valid directory. Sorry, wrong one. The schema cache, which I've preemptively filled, or the cache root directory, this is mainly used for the Azure event hubs, and it's where the event schema files or the data contracts are stored locally. I'm not using Azure, so I'm just going to keep it with this valid directory. The last thing is the loggers. I've got a string here that I'm going to copy in. And what this is saying is we want to log to the Jade event streaming demo, event streaming producer, logs folder, and we want the log to be called producer underscore and then the name of the producer, which if we go back to our event stream producer config, we're not leaving the config, the shortcut we're using to start it, it's going to be called Jade event producer. And this is just so you know when you have multiple producers running, you know which producer has created and is writing to which log file. So now that this has all been set up, we should be good to run the Jade event stream producer. And it started. Now, the next step is to run the Jade event stream consumer. Now, in this demo, I'm not going to touch much on the consumer or Kafka side of things, as they're a bit outside the scope of Jade, and it would take a bit longer for me to cover everything than the 1 hour I've been given for this presentation. But essentially, this consumer takes the JSON data off the event stream and pipes it into a SQL database. I'll also open up my SQL database here. I'll connect to it. And we'll have a quick look at it. So we've got some tables defined in our database that pretty much match what's coming out of our Jade system, so that our event stream consumer can take this JSON data and pipe it straight into the SQL database. Look at the top 1,000 rows of the customer table, and it actually has some data in it. So I'm just going to go ahead and delete that data really quickly. So I've deleted all that data. If we run this query again, we now have no data here. Great. So now I'll go back to my Jade system, and I'll run that Jade script again to create some data. This will create those Jade change capture files. The event stream producer will then grab those change capture files, produce events, push them to Kafka. Once they're on Kafka, my consumer, which is subscribed to the All Jade Events topic, will read those events and push them into the SQL database. So I've just run the script, and if we go back to SQL and we run this query again, we now have everything back again. Now this is pretty quick, and I'll try and show you. I'll update the customers rather, and this will just add a $sign to the address to field. So I'll run it now and then quickly bring up the SQL database and refresh. And there, all our customers have been updated. Now, if we go into our Jade system one more time and we look at the change capture directory, we can see there are no longer any change capture files here. This is because after the event stream producer has taken those change capture files, serialized them into JSON, and pushed them to Kafka, it will put them into the process directory. And that's pretty much how this works. Thank you for watching. I hope you learned something new, or at least enjoyed the presentation. Cheers.